Lesson 12-2, Example 2, looking at experimental probability. And our objective is to find how we would determine experimental probability. And experimental probability is an estimate of the theoretical probability, and the theoretical probability is something we'll get into in the next lesson. But experimental probability is an estimate of the number of times that an event happens out of the total number of trials that you'd have of an experiment. And probability, you can also write it, you'll sometimes see it as a large P, and then there'll be parentheses oftentimes indicating what you're taking the probability of, so some event. So we could say the probability of some event E is approximately the number of events out of the number of trials. So you'll see sort of it show up this way when you're writing things oftentimes in mathematics. So let's take a look at an example here. Let's take a look at Mr. Crow. For 1 month, Mr. Crow recorded the time at which his train arrived. He organized his results in a frequency table, and that's this table right here. And frequency just refers to the number of times that something happens. So the time that the train arrived, it arrived between 6:50 and 6:52, and that happened 7 times. Between 6:53 and 6:56, it arrived 8 times. And the train arrived 5 times between 6:57 and 7 o'clock. So we want to know the experimental probability of the train arriving between 6:57 and 7 o'clock. So I could write that as P of between 6:57 and 7 o'clock. So I want to find out, this is the outcome I'm specifically looking for. P indicates probability. So remember, it's the number of times that event happens out of the total number of trials. So 6:57 to 7 o'clock, the train arrived 5 times. The total number of trials would be how many times the train arrived, the times that he looked at. So that would be 7 plus 8 plus 5, which would be a total of 20 times. So there were 20 times that he recorded the arrival of the train. So we could say our probability is 5 out of 20, or we could look at that and say that that's equivalent to 1 out of 4. So if I think of it like a fraction, I can reduce that down. So I can say that the probability of the train arriving between 6:57 and 7 o'clock is about 1 out of 4. Let's take a look though. What if we wanted to find the experimental probability of the train arriving before 6:57? So before we were finding out the experimental probability of it arriving at this time, now we want to know what is the probability of it arriving before that time. So the train arrived before 6:57 7 times here, but it also arrived, this is also before 6:57. So the total number of times it arrived is 7 plus 8. So we would say that the probability of arriving before 6:57 is the number of times that event happened, which would be 7 plus 8, which is 15, out of the total number of trials, which is still 7 plus 8 plus 5, which would be 20 times. So this would be the total number of trials. And 15 out of 20, we can simplify that to 3 out of 4. So our probability of the train arriving before 6:57 is 3 out of 4 times.